Okay, we're going to have a look at an exam question about thermistors. It's a classic voltage divider question. Two students have built a model house. They want to install a fan that will turn on when the temperature is greater than 20 degrees. Okay, so read the question closely. And the key thing to start these questions is to analyse this graph that's provided, which gives you the resistance versus the temperature. Question 5 is very simple. What's the resistance of the thermistor when the temperature is 20 degrees? You simply have to read it straight off the graph. So the temperature is along the bottom, temperature is 20 degrees, read it off the graph, and you see that the resistance of the thermistor is 1500 ohms. So that's an easy 1 mark. The second part of the question asks you to design a circuit from the components listed that gives you a voltage of greater than 4.5 volts at the input of the switching circuit, and so turn the fan on if the temperature is greater than 20 degrees. Now you've got to draw a circuit here, and it takes a few steps to think about. The first thing you need to do when answering these questions is firstly draw the simple voltage divider circuit. It tells you it needs a battery, a thermistor and a resistor. So draw each of those things in series. Then you need to look at the logic of what's happening. So do it in simple sequence. Reading from the graph, when the temperature is greater than 20 degrees, the resistance of the thermistor here must be less than 1500. So we're in this zone down here. Write that information on the circuit. Now you know to turn the circuit on, the voltage across the output of the switching circuit must be 4.5 volts or greater. That'll switch the circuit on. So write this bit of information next to the circuit as well, so you know exactly what your circuit has to do. Now this next bit takes a little bit of thinking about, but if you follow it clearly, it's not as hard as it appears. The switching circuit must be put on the second resistor, not the thermistor, because you want the voltage to be going up as the temperature increases. On the thermistor here, you notice the voltage, the resistance, and therefore the voltage across it is actually going down as the temperature increases. So we don't want to put the switching circuit on that. We need to put the switching circuit on the other resistor. So draw the switching circuit across the second resistor, the other resistor in the circuit, and then you know that that needs an output voltage across that resistor of 4.5 volts to turn the switch on. You can calculate the value of this second resistor by using the voltage divider formula. So you know that the ratio of the voltages across each resistor must be the same as the ratio of the resistances, and also that the voltage across each resistor added together must add up to 6 volts. So if the thermistor is at 1500, then the second resistor must be 4500 ohms, because it's got to be 3 times the voltage across the thermistor, so 3 times the resistance. So write that clearly on the circuit and include these other components that you've been asked to put in clearly in a series circuit with this switching circuit across the second resistor and all the values written in, and you should get full marks for that question.